So, okay, nice. So about my background, I'm a human-robot interaction researcher. Human-robot interactions are about how to build robots that can interact and collaborate with humans. So we use in our field we use almost every kind of AI field. We are not just limited to deep learning and not limited to machine learning. So when you build a robot, usually what you do is you use machine learning and deep learning for perceptions, for the robot perception. But then when you have to plan and you have to act, you have to make sure that the robot is working as expected and do what it's supposed to do, because you are working in an environment that have a lot of safety concerns. You don't want the robots to punch you, for example, or to start hallucinating and give you make stupid things. So what we do is usually we use symbolic AI. So symbolic AI is a field of research that is really old. When people started to study human-robot interactions, AI, they really quickly came up with neural networks ideas or genetics algorithms. But the thing is, at that time, the compute power was not enough, so researchers started to study how to make working systems without this constraint of the computations and without this constraint of the data. And basically what it means is that symbolic AI is more about logic, formal logic, and how to integrate knowledge and symbolic manipulations for the AI to be able to plan for the long term. So there's actually a field in AI that is called symbolic planning, that is really working well. But the problem with that field is that it requires expert knowledge to make it work. And basically, what we saw today in the machine learning community, is that they want to tackle problems that are historically was tackled by symbolic AI with machine learning. And what we see today is that it doesn't work very well. So I will tell you about my background a bit, more specifically about what I've done during my PhD. So during my PhD, I was working on a field that is called a domain that is called situation assessment. Situation assessment is one of the other things to do when you're doing robotics, because it's involved understanding what is around, understanding the intention of the person that you are working with, and be able to leverage symbolic AI, so symbolic planners, etc. So usually we work with predicates-based architecture with object-level descriptions, because humans have this representation of objects, and it's really key to understand why we keep using this kind of models, because when you interact with humans, you want the AI to be able to manipulate the same symbols than the humans. So you want the AI to be able to understand us and have this understanding of the environment, etc. So during my PhD, I was working on how to enhance deep learning. At that time, it wasn't when I started my PhD. Natural language processing was really starting to rise, and my work was on how to correct visions pipelines. So what I did at that time is that I combined the robot perception that we were using the perception using detectors like single shot detectors and stuff like that to be able to know where the objects are in the scene and where the people are in the scene, and based on that we computed some predicates about the environment to know if an object is on a table or if it is on inside a bin. What does it mean in terms of semantics? Based on that, I was my first work during my thesis was how to combine the robot perception with the simulation engine. So we used a simulation engine, physical simulation, like you can have in a video game, and the robot needed to perceive the objects beyond the perception, so beyond the camera. Even when the object is occluded, we wanted to be able to compute those predicates, and for that I've combined so the robot perception with this simulation, with his simulation engine, and basically what we were doing is we detected inconsistencies in the scene. For example, when the robot is seeing an object that is floating in the air, it means that more likely the object has been grasped by someone, and we were able to detect a lot of the actions basically that the person was having, in order for us to plan a collaboration, manipulation collaboration. So when you are the basic task that we do in robotics is we have a tower of cubes and we want the robots and the humans to collaboratively build that tower of cube, or doing Hanoi tower. I know Hanoi tower is a really classic problem in symbolic planning, and it's a problem that is not yet solved by any large language model today. And my guess is that we will never solve it if we just use large language model like we do, like people do today. So then I want to talk to you about what is wrong in the AI space today. Basically, it's a lack of knowledge. It's a lack of knowledge in other AI fields. People think that machine learning is AI when it's not even. It's just a subfield. It's just a subfield of AI. And basically, what we have seen these days is people are building vector-only databases. Vector databases are really nice. It's really nice ideas, but you cannot rely. You cannot rely on them for complex tasks, because you lose the structurality of your data. So when we started to build HybridAGI, we was really surprised. Imagine, we were working with graphs, and we selected Redis graph. It was a graph database basically, and during the first year of HybridAGI we were struggling a lot because of the bad choice of other AI researchers or other AI so-called experts. Because, for example, Redis graph, Redis just stopped their support for Redis graph. So we struggled a little with that, and they decided, for I don't know the reason, that vector-only database were the new thing, and they completely dropped their graph database. So now there is another company, FalcoreDB, that followed the work. They continue Redis graph. So we kept using that software stack. And also another another big mistake that people are using are doing these days is doing React agents. So what is the promise with React agents? You have to understand why they dropped any way to enhance the way we make agents. And basically it was because of the beta lesson. The beta lesson is a book about how learning methods have evolved during the past 20 years. And the hypothesis is that we don't need to include structural knowledge, and if you use algorithms that really work on the smaller information levels, so the bits, or for example the pixels, if you're doing image vision stuff and stuff like that, you will have better systems, which is true. But machine learning is not sufficient for building robotics or complex application. And the problem is that React agents are based on the false promise that large language models are going to be better and better the more compute and the more data they have. So people are really stopped to look at how to build AI and how to build a complex system. And for example, I will tell you another story. So that's why we struggled when we started HybridAGI. We started like everybody, like we started using LangChain. And for the question, you can ask them in the chat. I will answer them. Don't worry. And we started to use LangChain, and LangChain at the beginning was starting, for example, to implement each paper that come to AI. So they were different kind of agent architecture that they were implemented and used them. So anytime a new paper was coming with a new agent architecture, they were using it to implement that agent, and it was really a great work. But what we saw is that for I don't know the reason, maybe because they were acquired by large AI companies, they only focused on React agents. So now today, how do you enhance the result of a React agent? How do you enhance the reasoning? The only way to enhance that reasoning is to use a fine-tuning and to basically enhance your neural network. Because the React agent, if you look at how it is working, basically you have different tools. What I say here, it work also for function calling. So it basically agents based on purely only function calling doesn't work, and React agent doesn't work. And why? It's because you basically give the deep neural network the ability to choose which tool it needs to use, and that's it. The only knowledge that you integrate inside this this architecture is the first prompt. So people started to find fancy ways to enhance their reasoning. When it means reasoning, in this case, it means how to choose the tool and how to leverage them, using only the initial prompt that you give to the agent. And people started to notice that if you give them like a personality, like you are a software engineer or you are anything, it was working better. So it's true, but there is some limitation in that, and the limitation is that prompt only cannot leverage human knowledge, because actually you modify the prompt. So you try to integrate that knowledge. You tell the agent, oh, you need to do that and then that. But at the end, what will be the neural network will choose a tool not based on the prompt you used, not only, but it's a subtle combination of the prompt you give it and its internal knowledge that the neural network was given during the training. So basically, if you ask React agents to perform a task that it didn't see enough in its dataset, it will not do it. It will hallucinate. So when we talk about hallucination is actually it's not a good word to talk about that. I'm against the anthropomorphization of AI, and I think we don't need and we shouldn't think about AI as humans. They are computers and they are stochastic computers. So the thing is how to enhance this reasoning, this flow of actions. And it became really clear in our mind that basically long chain, long flow, Pinecone, every new startup that you see nowadays that is going really great, but it's going great by doing false promise. And the false promise is that, yeah, we can just wait for GPT-4, GPT-5, GPT-6, GPT-7, and it will solve every problem. We don't need to care about the architecture, and we don't need to care about the structurality of the data and the structurality of knowledge. What we see today, when we started HybridAGI the first year, almost nobody was working on the agent system. For us, it was really disappointing, because when we started HybridAGI, we started to talk about it to other startups or other companies, and they were all they wanted just to do RAG or just chatbots. For us, chatbots and RAGs are nice, but they are not they are not the future. For us, the future is agentic. And we think that basically people are doing it wrong, completely wrong. So this is about what differ HybridAGI from other softwares. Basically, if they are using React agents, it's not explainable. It will never be, because you actually give your neural network the ability to choose the tool it will have to use. Okay? And because the neural networks are black boxes, we cannot ensure, and that's really a key point, we cannot ensure the methodology they will be using. Okay? That's a key point. So you cannot, if someone tells you that we are building an explainable system and we use React agents, it's bullshit. They don't even understand what is explainable AI. That's first thing. Second thing is that vector-only database are not enough powerful. They are useful for simple tasks, but as you need more knowledge and leverage a knowledge that is not present in the training dataset of your neural network, you will need a way to structure your knowledge. Okay? So this is really the key aspects of HybridAGI. In HybridAGI, we have our own agent implementation, which is a graph interpreter, and we use an hybrid vector and graph database, because we have the same capability of the vector database, but we have also the structurality of the data, which allow us to make better system and to have really complex systems. So this is about HybridAGI. So now I want to talk about the current limitation of HybridAGI. So the current limitation of HybridAGI is that we are the only ones that are really looking into neuro-symbolic systems. what does it mean? It means that we had to invent and to made a new programming language for large language models, and even if we use Cypher, which is an already existing language, the neural networks don't know the subtleties of our DSL, and they don't know how to plan correctly. So actually we can plan with them. So when I mean planning in HybridAGI framework, it means for the system to be able to create its own graph program. Okay, so basically it means for the system to be able to program itself. And so we are currently limited by this by the approach that other people choose for AI, and we are trying to leverage that and to enhance that. So what we are currently doing in HybridAGI is that we are actually doing our own large language model, not because we just want to have a new large language model that is self-made. No, it's because it's required to be able for large language models to plan for long term. Okay, but the key aspect, and this is something Jan LeCun said, and it's really key to understand, is large language model cannot plan, and they will never be able to correctly plan. Why? It's because they don't interact with the real world, and they don't have the insight that us developers have about the real world and about how a system should work. Okay, so what they do basically, a large language model is basically a stochastic parrot. Okay, and it will output what it have been trained on. So if you, for example, try to plan for a system, the first thing that you should talk about your system is giving it the affordance. Affordance is a concept in that we use a lot in human-robot interaction. It means being able, it's being conscious of its own capabilities and what can be done, what's the action you can have. Okay, what you can do. And large language model don't have that. So unless you prompt them by saying them, okay, you can do this, give me a plan, they will not be able to plan anything. Okay. But the thing is, even if, for example, let's say in next year we're gonna have our own large language model with a deep understanding of its own domain-specific language. Okay. Our hypothesis is that it will not be enough. Okay, we will still need to have humans to modify and correct the plan that this kind of system will give you. Okay, so we need a way for human and people, for humans and machines to have a common language, a way to talk to each other and to enhance our understanding. It's like a collaborative task. Okay, we need for AI system to be to talk the same language than us. Okay. So this is about. So this is really the main key point of Neuro-Symbolic system. A Neuro-Symbolic system is a system that is built to have a collaboration between the human and the machine. You don't give a perfect autonomy to the AI because you know it's gonna do bad things. Okay, so you need a way for you and a way for the system to understand what it's doing. And one way to first understand what LLMs are doing is for them to have a predictable behavior. Okay, So this is really key. That's why HybridAGI, when the agent is interpreting the graph program and is behaving, we can assure and we can make sure that it's gonna follow the graph. Okay, this is key to our system, and that's why we don't use React agents, and we'll never use a React agent in HybridAGI. Okay. So actually, the graph programs are actually a way, and this is key to understand. It's a way for us humans to encode in a formal way, okay, without ambiguity, the behavior that the system should have, okay. And of course, the system can, at the end, modify or give you advice for to have a better graph program, etc. But we will always need a humans to monitor that program to verify that is that program correct or not. One way to Baby, I will answer your question. We can use existing large language models, but we can use them for the execution of the program. Okay, but if you we already tried to do that, and if you try to use them for planning, so for self-programming, they lack a lot of knowledge. Why? It's simply because LLMs are stochastic parrots. So if you don't have graph programs inside their training sets, they will not be able to grasp the subtleties of your language. Okay, they cannot learn a new language, despite some researchers saying otherwise. It's not true. They are really limited in their understanding by the data they are fed on the pre-training, and it's something that's even deeper than just fine-tuning it with the knowledge of because you could obviously fine-tune them to be able to you can fine-tune them to be able to have the correct syntax, but actually if you look at the graph, they missed some key information and some key knowledge that a human will understand in a glance. Okay, so that's why they are not even comparable with humans, and they will never be in the current state of the art. Okay. So about the roadmap that we have. So obviously we want to build our own large language model, not because it's fancy or because we need money from people. It's because it's needed in a really for the system to be able to have better plans. So to better program itself, it needs to have a knowledge about our domain-specific language. Okay, even if it already knows ciphers, it doesn't know what's look like, for example, a trace of it's just extrapolate from the graph that you give them some instruction. For example, when we tried to study that the first year, we were inspired by a paper that is called Voyager. Okay, and you can look at this paper. It's really interesting. First, they solved the compositionality problem, but the problem is that they solved it for a game that is called Minecraft, that everybody knows. And if you look deeper in the implementations, they were able to do that because the LLM already known how to program a bot in Minecraft, because they have read the documentations in using some API to build Minecraft bots. Okay, but if you come up with a new task, if you ask LLMs to plan for something that it has never seen, you have a lot of problems. You have most of the time the program will be wrong. Okay, that's why currently, even if people say, okay, we got 99% on human eval. What is human eval? First, human eval is a code benchmark, okay? And this code benchmark have several problems. So the first problem, of the benchmark nowadays in the ML space, first thing is they have a really big contamination problem. What does it mean? Basically, it means that people, machine learning scientists, are frauding. They don't show to other researchers the training set of their large language models, because they are giving in the training set the answers to the benchmarks. Okay? So this is a really big problem that we see nowadays in the machine learning community. They are driven by money, and they are driven by greed, and they are not driven by science. Okay? And the problem is that we cannot trust these benchmarks. So basically, all benchmarks that we see nowadays in machine learning are almost all biased. Okay? They have the answer to the benchmark in their training set. So basically, you give them the answer. It's cheating. It's basically cheating. Okay? And they don't. The worst in that is that they build all their communications in, okay, we got 99% on MLU or 90% whatever, or X% on human eval, and it's great. But if you look deeper in each benchmark, first you see that these benchmarks are often really simple. Okay, they are simple. The answers are most of the time in the training set of the large language model, meaning that actually what this benchmark are testing is not the reasoning ability of the large language model, but is the ability for the large language model to recall an answer that he already know. Okay, they don't come up to the conclusion themselves, and that is something that is really investigated by other researchers in the field. Most of the time they are not researchers in Google or in large companies, but they are researchers that are really trying hard to leverage the limitation of large language models, and they don't have enough credit because those researchers do a really amazing job in showing that these benchmarks are biased and we should not trust them. So if I can give you an advice, if you are building a system using large language models, is build your own benchmarks. It seems obvious, but most of the time people don't do it. They just follow the hype, use the large language model. It was like the last large language model, without testing them, without benchmarking their own task. Okay, so if you want to build a system using a large language model, first thing first, do your benchmark. Write some examples and test yourself your system. Don't trust other people. Okay, you should have a really critic thinking about how the system gonna perform in your task, in your specific task. Okay, that's how we saw like really surprising stuff. For example, when Llama 3 came out, we were like, okay, this is so nice, finally we're gonna have a open source large language model that's gonna perform really good in a lot of tasks. It got really good percentage and really good score on many benchmarks. But at the end, when we started to benchmark it, what we noticed that first, Llama 3 is unable to leverage in context learning. Most probably because it was trained on data without long context, and the context was not really the tasks that they were trained on was not really difficult. Other thing that we noticed is that models that are trained based on multi-agent system about the question about if the fine-tuning is enough, actually I thought it will be enough and we kind of eluded the possibility that we don't want to spend money unnecessarily, obviously, and the pre-training of a model can be really expensive. So we thought, okay, let's just fine-tune the models. But the thing is that fine-tuning a model, when you add new knowledge, it's now it's a bit more studied. We noticed that they perform poorly. So there is a problem with the fine-tuning. Okay, the fine-tuning will not solve your problem. That's for sure. If you want to have an effective strategy to build applications based on large language model, you should first focus on in-context learning, giving them more information in the context, in the prompt. Okay. And fine-tuning should be only used at last resort. Okay. And that's also why we've built HybridAGI, because if you look at HybridAGI, it's basically an agent system that's leverage in-context learning for each step. Okay, it's not, we don't just leverage in-context learning for let's say the initial prompt that you send to the agents, but we have the ability to at each step add additional hints, additional information for the prompt for you to correct each step. Okay. So about how to leverage and how to come to tackle the current limitation of large language models. And specifically for HybridAGI, the only way for us to be able to provide and basically if we to be that's why we called this project a Neuro-Symbolic AGI. Okay. So what is an AGI? My definition of an AGI is a system that can perform well on a really wide range of different tasks. Okay. And today LLMs they cannot do that because you need first to have the task inside your data sets before it's performing well to unknown task. But our guess and our hypothesis is that they lack planning. Okay, they cannot plan in the long term for tasks that are unknown or difficult. Because if you want for a large language model to tackle unknown task, it will need many iteration, many action, observation to be able to correct its understanding and its actions based on the context that he got from acting. Like when you do an agent, you make them act, and then you take that observation and you put that observation inside the prompt. Okay. And based on that observation, if your large language model is intelligent enough, it will understand what went wrong and it will correct itself. Okay. But actually, the correction of the LLM is possible because in their training set they were trained to see already this mistake happening. So that's why when you sometimes when you want to tackle tasks that are not common or not really widely done, like if it's not a common task, your LLM will have problems to even correct itself. Okay, it will think, okay, this is okay, and basically what we see is the same limitation that we had when with early on large language models. Okay. Okay, good question, Fabish. So what's the difference between HybridAGI and knowledge graph with LLMs? This question is somehow simple to answer. If you look at knowledge graph, what is a knowledge graph? Okay, a knowledge graph is a system that represents knowledge. Usually, it's knowledge triplets. You have it's something that I'm used to work with because when I talk in the beginning of the workshop, when I talk about my background is actually on knowledge graphs and ontology systems, okay? And what you do, you model knowledge, okay? But often, and most of the time, we are the thing is that we don't only use knowledge graphs for knowledge, so to answer question basically, but we also use it for planning, okay? So planning and knowledge representation are two different problems in AI, okay? They can help each other, but they are not related. When you do planning, your knowledge is about the actions that you need to do, okay? And when you do knowledge representations, you are basically working with knowledge triplets, and you want to do inference on new knowledge. For example, let's say you have a knowledge graph for medicine, okay? You have all this medicine, and you have the symptoms that it's cure, and you have a triplet that represent the connection and the relation between all these concepts, okay? HybridAGI, what we've done basically with HybridAGI is we integrated a planning system based on a knowledge graph inside a knowledge-based system, okay? So actually, HybridAGI is a way for us to work on every problem that we encounter with LLMs, not only knowledge representation, because the knowledge representation it's related to the problem we see, like people are using vector-only database, and this vector-only database cannot capture the semantics of the relations between concepts because they lack the graph structure. This graph structure you can give them. Basically, if you compare a knowledge graph with a LLM, it's basically in HybridAGI just the fact memory, okay? It's only the fact memory. What we've done with HybridAGI is we applied this knowledge, this way of thinking, to not only knowledge but also for planning, okay? That's why HybridAGI got a program memory, and that's why HybridAGI have graph based programs, okay? Also, a really big inspiration for us is Neuro-Symbolic programming, okay? So Neuro-Symbolic programming is an emerging field of research that started a few years back when we noticed that detector-based architectures and basically neural networks used for vision systems were not performing well, okay? And there is a number of people, a number of researchers that studied how to enhance these vision systems with programs, with neuro-symbolic programs. I will, at the end of the workshop, I will put some papers about these topics, but it's really key to understand our approach to AI. So we have a neuro-symbolic approach. And what makes us different from other people that claim to be a neuro-symbolic system? Most of the time they don't understand what is a neuro-symbolic system. They just took a buzzword, they think they know what is symbolic AI, which is good because most computer science students know what is A*, know what is there is lots of symbolic AI algorithm that's Dijkstra or many things that people study during the college, and they think that because you use a neural network with that, it's a neuro-symbolic system. No, for being a real neuro-symbolic system, you need a synergies between those two. You need the neural network to be proficient at manipulating the symbols of the symbolic system. So you need the two working together. That's why if we didn't add the capability for HybridAGI to program itself, so to build its own graph program, it will not be a real Neuro-Symbolic system. If you take just the execution of the graph, and almost every system that is using graph for LLMs, they are basically doing those two systems in isolation. Okay, what is key is to have them working together. Okay, and what it means that your symbolic system needs to be somehow readable and understandable by the large language model. Okay, if it's not the case, if your symbolic system output an enormous JSON that doesn't make any sense for the large language model to work with, it is not a real neuro-symbolic system. And that's why we choose Cypher, because Cypher is really efficient in modeling and having a short prompt with all the knowledge, with the label on the edges, with all this, really easy for the LLM to understand what is going on. Okay, it's not enough, because we need to train them on our DCL domain-specific language to enhance the results. Yeah, graph programming is really a new. It's not new. We didn't invent it. It's really something that is really many people work on that in the research community, but it's only researchers that work on that, and nobody in the AI space, in the commercial AI space, is working on that because it's not known. And so basically there is a lot of research happening in what we call genetic programming, graph-based genetic programming. It's also another area of artificial intelligence that we didn't explore yet, but we are really interested in that aspect, and it will be like our future work for the next years, to be able to be sure that we work toward AGI system. Because at the end, what we want is an AGI system that is controllable, explainable, and that can be... Oh! Nice. Nice. But it's something that is emerging. I mean, it's not comparable to neural networks that have been used for decades, okay? Graph programming is something that is starting to emerge and to be used in real world. Personally, I only know really a few researchers in my area, my domain, that work on that problems, and they are doing really well in science, because they are able to publish in really good conferences, because this concept have not been studied enough, and it's really an emerging field of research. The key thing is a neuro-symbolic system, and if you for example, if you want to search for problems and for other papers about neuro-symbolic system, you should look for neuro-symbolic programming. Okay, that's the term that we use in science, and that's where you're gonna find a lot of good insight about how to build this kind of systems. So here it is. Now, if you have time, what we can do is I can show my screen, run some demo, and show you a bit a more practice workshop to show you how the database work, and for you to see a bit more of how to explore HybridAGI internal database, and how to leverage that. Okay. If you want, I can also delete my virtual environment, so we can just start from the same page than you, and you can see all the process for setting up the system and for setting up things. Okay.
Johan, I have a quick question.
Yes. Yeah. Of course.
Yeah, because remember I shared with you, and I think I also did put it in the one of the channels
Yep.
of your server,
Mhm.
the the issues that I had trying to set up Llama 2, or was it Mistral? Mistral, because you recommended it. So like, and bear with me here because I really want to phrase the question right.
Yep.
Everything you just said intuitively just sunk in. All right, I'm a communication person, and like with linguistics and stuff. Everything you just said, like you're preaching to the choir. The problem is that like, so this is gonna be interesting watching you do this because I guess let me just cut to the chase is that if someone's background with like actually building an LLM, like it's not that, you know what I mean? We don't have that much of a background in it. Like I know how to code, you know what I mean? But I'm
Mhm.
not that good at it. So like, but it sounds like someone can still do the work, even if like you don't have a heavy background with like building LLMs. I don't know if my question is clear.
Yeah. So what we wanted to build with HybridAGI is a system that can be leveraged by programmers. Okay. So we didn't use any complicated concepts. I mean, in the theory side, it's really complex. But for you to leverage it, you don't need to understand this concept. Okay. Basically, what we saw is some people try to, for example, to copy us and to copy our work, and they don't even get the basics of the why we choose and why we took those decisions, and they are basically doing bullshit. Okay. But it's not the point. The point is for you to leverage HybridAGI, you don't need that knowledge because we already package everything you need inside the software for you to use it. So the only knowledge that I encourage people to have is prompt engineering and programming. You should be familiar with programming and with prompt engineering. Okay?
So all right, so I'm sorry, but Johan, one last. This is a very quick one, right?
Yep.
You've looked at some of like I did share the Google Colab notebook, right? So I
Mhm.
guess a person like me, and just let's just I'm being blunt with myself. Guy, a guy like me, I felt like the Joker from Batman. A guy like me, can I, you know what I mean? Like, am I in a good position to, let's say, take advantage or contribute to the core of your work, to like
Yeah,
take
yeah.
it further?
You are. Actually, for you, if you want to leverage HybridAGI, what you should do is learn. Okay? What our hypothesis is that people doing AI are basically doing it wrong, and if you want to do it right, you will need to learn. You will need to get a sense of what LMM are able to accomplish, what they can't, and you need to experiment yourself. You will not find the knowledge by asking ChatGPT. You will not find the knowledge by only reading some paper on neuro-symbolic programming. You will find this knowledge by experimenting yourself. Keep in mind that you are humans. You are the best learners. Okay? AI is not a good learner. Okay? That is really fundamental, and people tend to forget that. AI are stupid. You are much, much, much more intelligent than any AI system. Okay? So you need to experiment. You need to see what's happening when you change some things in the graph program, how the system behave, and you will build your internal representation of of how things work and how you could enhance that. Okay, this is key. This is really key. Is it okay?
Thank you so much, Johan. I just want to say thank you so much for the answer. I was actually typing it out. You gave me, I think, yeah, and I really like the fact that, like, yeah, the theory. Thank you. Basically, I feel much much better about my.
Okay.
Sorry, Johan,
Mhm.
just ask it. Um, Everything you said resonates 100%. But you mentioned, I want to ask the question I asked there, like, how does the ability for the system to be able to like generate and understand DSP improve the system's ability to reason? Can you explain that some more?
For the training of the LLM, we are actually working on it. Uh, if I explain it to you, it's really simple. It's so damn simple. Really that's what. Actually, we recently read a paper from DeepMind that is called Next, And basically what they've done is that they got the same idea than us, except that they were working on Python learning and not on their own DSL. But basically the logic is the same. It's really the same. So for a large language model to reason and to understand, you need to show him the graph, so the program, and you need to show him the output of the program, but not only the final output, but all the trace. Okay, and that's why we choose to build a domain-specific language that incorporates a lot of natural language. Okay, that's the key reason, because by integrating natural language, by making a programming language that works with natural language, we can leverage the LLM understanding of natural language. Okay, this is kind of obvious, but nobody thought about it, or not many people thought about it. So the key things for us, if you look at the README, we showed a basic program, okay, and we showed the trace. With that two elements, as human, you are able to understand how it works. Okay. The problem with large language model is that they need more than one example. Okay. So what we are actually doing right now with our intern students is we are basically gathering a lot of data and a lot of programs, and we are basically learning, making enough data for the LLM to learn. Okay. So the goal here is basically to gather data. Data is the pinnacle of a large language model. It's not about compute. It's not about having the bigger large language model. It always and have always been about data. You need high quality data, structured high quality data that were verified by humans to avoid any hallucination, because what we call today hallucination is a stochastic artifact. Okay, it's an error basically. Doesn't mean errors are bad. What I want to emphasize is that when the creativity comes from errors. So large language models are able to be creative because they have this hallucination. It's actually a feature. It's not a problem, but we need to understand how they come up with these errors and why they come up with these errors. Basically, when I was starting to work with HybridAGI, what we've done first is we've built the hybrid vector graph database. That was our first milestone. Okay, and because it was so obvious for us that vector only database was not the right thing to do. Unfortunately or fortunately for us, not many people noticed that. So we struggled to build that database. And then what we've done is we've implemented a React-based planner. So we had a planner that was decomposing the task, and we asked a React agent to execute the task. Okay, and when it was executing the task, we noticed that it was doing bullshit. Basically, the React agent was not performing well at all. Okay, and the problem. So when we saw this problem, we started thinking, how could we enhance this final execution of the leaf, I would say. So you have a plan. The plan is a graph, and the execution of each leaf of the plan is in traditional or what's nowadays people are doing is React agents that handle this leaf the leaf in this plan, and it's gonna execute this atomic step. Okay, but the thing is they don't do it well. So our insight was we need a formal way to make sure that the agent is executing the right things and executing the right methodology and the right workflow. Okay, That's why we started to integrate workflow-like structure inside HybridAGI. Okay. Also,
This is genius.
also,
Go on, sir.
something that people don't get is that why did we choose to have decision and action? Okay. Basically, large language model, when it started, like nowadays they are trained on almost anything. Okay, but when it started, large language model were really trained only to do question answering. So our take was, why don't we use that at our advantage? Why instead of asking them to plan, we just ask them to answer questions and generate some stuff? Okay, because basically they are answering machines and generating machines. Okay, but the generation is somehow not really reliable, so you need to put a lot of help for the generation to be useful. But actually the question answering is really good if you give them all the information to answer to a question, they will answer correctly. And that's the power of LLMs. Okay, you give them the correct context, you ask them a question, and they will answer correctly. So we use that power to navigate inside the graph. Okay.
Yeah, so just to repeat what I had, so I think there are two things that struck out to me. So you said there was a decision to use a natural language type programming structure instead of Python, so that's why you chose Cypher. And then the other thing was
we also used it because Cypher is a query language for graph database. What does it mean? It means that it's actually really easy for us to it solves many engineering problems basically. Because it's Cypher, you can just load it inside the graph database, and so you have, in terms of engineering, you have your database that contains all the plans, all the graph that people can carry, display, check out, and correct on the fly. Okay, so if you want imagine you are running a business. Okay, you are running a business and you have some React agents. The agent is not working. What do? The only solution you got is fine-tuning. Okay, but fine-tuning is expensive, doesn't work well if your data is imbalanced. Okay, and you need an exponential data for the LLM to perform linearly, to enhance the performance of the LLM. So you put a lot of burden in actually enhancing something that is broken by definition, by structure. Okay. What you can do with HybridAGI, you have your agents, and some of your clients tell you, okay, this is not working, it do shit, whatever. Okay, you connect to your database, and you can check the step that your client is talking about, and you can adjust the prompt. You can adjust the workflow. Okay, exactly.
Yes.
That's the key.
To train the system, and then the system uses that. This is genius. Please go on, because we're out of because of time. I want to see your demo and other things.
Yeah. So I'm gonna launch that. Okay. Partager. Okay. Tell me if it's good for you, because if you see everything correctly. Is it okay? Because I can't.
Looks like I just need to figure out how to expand your screen.
Okay.
Yes. So I think if you double click on his screen, it makes it bigger.
Let me try it. Thanks about that.
Okay.
Oh, nice. Thank you, Baba. Thank you.
Okay. So first I will remove my.
Oh, okay. Sorry,
I will
you know
start
I
to
cannot
install
see you
everything.
on anymore.
Ah, you don't see me? What? Ah, yeah, it's normal. It's
No.
because the
What I was saying was, there was a silence, and so I thought you had muted yourself by mistake. I couldn't see you.
is it okay?
Now that yes, now I see you and myself and all of us
Okay,
on the inadvertent mirror.
okay.
Sorry, I'll just recommend. Can we hold the questions again, just to give Johan some time to present, and then later we
Don't
can
worry,
do that.
don't worry. You're gonna have plenty of time during the example to answer any question. Don't worry. Um,
Perfect. Thank you.
so, uh, okay. I start from the beginning, okay? For you to understand. Then
Okay, and you're using
I just deleted. Okay. Um, Poetry Insta. Ah oui. Okay.
poetry.
It's gonna take some time because there is the transformer library and stuff. So. Oh no, actually.
While it loads, if I may see something real quick. Oh, never mind.
Okay.
So are you doing this locally on your on your?
Yeah, completely. It's fully local, and you don't need I have a 3060 NVIDIA card, so it's not that expensive. It's really a basic GPU card for gamers.
This is an upgrade.
But you do
For
need a
getting a.
GPU to run.
Yeah,
You do need a GPU to run this.
you can do it on CPU, but it's gonna be really slow. So yeah, you need a GPU. You don't need the last high-end GPU, but you need a GPU for gaming, basically.
Okay, thank you, sir.
Okay. So here we are. So first thing, I will set up the knowledge base. Okay. So basically, I just use the Docker Compose. Okay. Now I can open a new terminal. I have to source the. Okay. Okay. So now I can connect to Redis Insight. Attends, wait. On va supprimer tout. Okay. So here is what you should have if you connect to localhost 8001. Okay. Okay, you click on I already have a database, and then you click here. So the host name is HybridAGI.
Johan, is it recording? Are you recording this?
I'm recording everything. Yeah.
Yeah.
I'm recording everything. Here you can put whatever you want. It doesn't matter. Okay. And now you can go here. Okay, read this graph. So let me refresh that. Okay, so this is test. Why? Okay, Poetry did the test. So now I'm gonna load and execute an example that I just gave in the. Okay. So let's start with a simple one. Okay, the RAG Python 3.
Sorry to interrupt you.
Yes.
Fabish says you're sharing screen, like he can only see you. So Fabish, I think you might see there might be like a fourth screen that is small, and if you double tap that fourth small screen, you would see it grows larger, and then you would see the screen, and you would see 3 other people with you on speaker.
Guy, you're like the screen whisperer.
So
You explain.
examples. Okay. I don't know if I also, that's something that I didn't show you because it's you should install Olama and run it, and the server will be running. But don't worry, it's explained in the documentation. But if you struggle with that, I can show you. I will answer any question about how to set up Olama and stuff like that. It's really simple. But so basically what we are doing is that we just launched an example. So we're gonna load the model and stuff like that. Can take some time. So here is the example.
Can you talk about the example?
Yeah, I'm going to. So here the example that I just run. So here you basically just need to import some stuff about HybridAGI, so the program memory, file system, etc. But here, if you want to write your own HybridAGI system, everything will look more or less the same. But what's going to be different is that part. Okay. So in the program memory, you need to add the cipher programs that the system gonna follow. Okay. And that's it. You put your graph program, okay, and then you give it some examples, and you basically run the optimization. This is the optimization that is provided by DSP. So there is different optimizer for DSP. What is DSP? Actually, as I said earlier, Longchain, the people from Longchain, Pinecone, every really successful in their term startup in the AI space basically did wrong with LLMs. And finally, I was so happy to encounter and to know about DSP, because DSP is made by researchers and they really understand what is going on with the LLMs and how to enhance them. So if I can give you one advice is forget about Longchain, forget about LongGraph, and forget about every framework that use them. Okay, they are basically doing it wrong. They just follow the hype, the new hyped library, and they don't understand what they are doing. DSP is made by Omar Khattab, a guy from Stanford, and he's really a really good scientist and really a good guy. So you should really check at it. Okay. For example, if you want to, so I can put that here. So if you want to build a system for LLMs, don't use Longchain. Honestly, it became really a shit framework because they were driven by maybe people from OpenAI. I don't know, but they're basically doing really bad work. And you should focus on DSP and on a framework that are made by researchers and serious people. Okay.
So we should ignore LangChain, Llama Index, all those ones. Just focus on DSP and HybridAGI.
DSP, yeah. So Llama Index, there are some interesting stuff in Llama Index, but actually Llama Index have been made by same kind of people. That's I don't know if it's the same people, but Llama Index, there are maybe 10% of their library that are actually useful, and the other percent is just nonsense. Because first, what people don't realize is that RAG and agents are the same thing. What do I mean? A RAG is a system that's gonna retrieve information and answer based on that. Okay? But an agent system is an AI system that's gonna use some tools, and mostly we use lot of tools. We use tools for what? For generation, but also for retrieval. So a good agent framework will give you a RAG system. Okay, by definition, a RAG is inside. If we modelize it as an ensemble, a RAG system is a subcategory of an agent system. Okay, you give it an objective, but the objective can be a question, and it's gonna perform some actions to answer your question. So basically, an agent system is some kind of RAG. Okay. So here are the examples. So what you can see, are you seeing correctly my screen?
Yes, sir.
Okay. So what you can see here is the steps that the model performed. Okay. So you have the step 0. The step 0 is the call of the main program, like you would do in any programming language. Okay. So your entry point is the main program, and the purpose of the main program is the objective that you just gave. It's the initial instruction that you gave your system. Okay, when you are doing a RAG, it's a question, but if you are doing an agent system that's do other things, it's gonna be your objective, the objective of the action of the agent. Okay. Then, in this case, we search for similarity. Okay. Here you can see that the query was not correct by the system, so it performed bad in that. But anyway, we don't have anything in the file system at that time, so it doesn't retrieve anything. So it checks if the answer of the question is in the context. Other things that is really important when you build RAG systems or anything is that the vector retrieval is not enough. The vector retrieval, especially with vector-only database, will give you the best answer they can give you, but that answer will never be enough. You need to ask your large language model to verify if the answer of the question you asked is in the data you just retrieved. If you don't do that, you end up with a RAG system that sometimes will retrieve the wrong information, and the LLM will come up with an answer that is just invented based on the information it retrieved. Okay? So this is really key. And here, so it is the answer in the context, so is the answer in the passage that it retrieved? No, obviously, because it's empty. So it chose to then perform a search on internet. Okay? And then we make them answer. So based on the search, it answers the question. Okay? And here we have the final answer. So we have this RAG. About this example, what is it? It's a RAG that populates its own knowledge. Okay? That's here. It answered the question that you gave it, and then it saves it inside the file. Okay? Inside the file system. So it saves the answer to the question inside the file system to be able to retrieve it afterwards. So if you keep asking the same question instead of looking on internet, it will use the file system in order to retrieve the answer. Okay. Okay. So here is the trace. We have a lot of examples. You can have it in your machine. I will not go deep in that. I prefer to show you the graph.
Sorry, another question. I don't know if you touch on this, but a lot of these systems are designed in such a way that they have the mental model of the user is going to be the one first doing the prompting. But if I want to design my AI system or my agent system in a way that the agent is the one that does the prompting, how can I achieve that with HybridAGI?
Okay.
You understand the question?
Yeah. So how to make proactive systems, basically.
Exactly, basically, yeah.
So proactive is never really proactive. Okay. What we have in robotics when we build proactive systems, okay, is we have some kind of events that trigger the system. For example, the events could be you just came in front of the robot, the camera detects that there is a person facing the robot, and it triggers an event, okay, and that event will trigger the proactive kind of behavior. But it's not never really proactive, it's event driven, okay. If you want to do proactive system, you always need to have an event that trigger the behavior, okay. The thing is that event may not be a phrase, may not be a query that the user is using, but there is an actual event that's coming from the environment. So it can be someone is looking at you, someone is doing something, is acting in front of you, so it triggers you a behavior. But they are never real proactive. I mean, there is always an insight from the environment coming from the system. Okay, that could be let's say you made a push in a repository and it triggers an agent that's then gonna verify your code and give you some advice or stuff like that. But they're always a system that's working.
Yes, I understand that. So, but what I'm saying is like, so if you look at most of the examples you might be passing onto your onto the graph, it's like the user says something, then or the user asks a question, and then this is the response the system gives, and then you can train and say, okay, this is actually the expected response. But if you want to reverse that, whereby yes, it's event driven, but what you're going to get from your graph is that the agent will say something, and then the user would respond, and so it's almost like inverted. Can that still be supported with HybridAGI?
Yeah, basically what you're gonna have to do is you're gonna have to stop the pipeline at some point to wait for the user input. Okay. What we've done in HybridAGI to because when you want to do fine-tuning or prompt optimization, you cannot have a user that is answering your question. Okay, so you cannot have this input because you cannot stop the pipeline and then wait for some kind of input from someone. So what we've done is we asked the LLM to simulate user input, okay, based on the historical data that the chat data, that the conversation that you have with him. That's actually the example that we gave in the README. They are fully simulated by the system, so we simulate the human.
I see.
So here is the graph of the file system, and as you can see, the system basically writed some files inside our file systems. Okay, and we can see if we look here. So here is the vector embedding, okay, the embedding vector of the content that we just put inside the file system, and here you have the metadata, the content of the file, etc., and you have everything stored in your database. Sorry, you have everything stored in your database, and that allow you to really understand how is it going and to inspect the behavior of the system. Okay, so this is for the file system memory, which is basically a document store. When we started to implement a document store in our hybrid system, we got the really simple thinking that what's the structure that usually people use to structurate their documents. And obviously this structure is a file system, so you have a file system tree, and we decided to implement this file system tree inside the graph database. So we got all the benefit from having a document store like you will have in a classic graph only database, but you also have the structurality of your data. Okay, so you kept the folders are a way for you to semantically separate information, and we kept that. And what is really cool about HybridAGI is that we implemented a way for the AI to check this structure by re-implementing some basic Unix command. So we already noticed that LLMs, because they were trained on computer, on Bash, on many on Unix commands and stuff like that, they were already able to leverage that. So they are able to navigate inside the HybridAGI is able to navigate inside its own file system, its own document store, and it does that by using the internal shell. Okay, so the internal shell is basically a shell that we re-implemented using the graph database. Okay, if you are familiar with hacking and malware development, what we've done is we kind of implemented a command and control system. So we re-implemented the basic Unix command to be able to navigate inside the system. Okay. Voila. Now I can show you another example. I will show you each kind of memory, okay? So you can have a better sense of what we are working on. Except for the fact memory, because I didn't finish the example for that, but I can show you after. So another thing that is really interesting in HybridAGI that nobody did, we implemented the kind of an episodic memory. So episodic memory is a type of memory that we have in human cognition that allow us to recall our past actions. Okay, it doesn't need to recall everything, because in human cognition there is a theory, it's called simulation theory, and it's explained why humans are biased towards remembering their own actions and not the actions of others. So that's why people tend to think about themselves before others, and because we have the memory of our action and what we thought, what we our emotions and stuff like that, and we have a special memory for that, and the knowledge about others is integrated in another kind of memory that we call biographic memory, that we plan to implement also. But this is a bit more tricky, so we didn't finish it now, but it's in the plan, in the roadmap. So here I can show you a RAG that remember its past actions. Okay. Okay. So. Okay, so the RAG now is working. It's executing the function, and it at the start it didn't have anything because it didn't perform anything. But the more it's gonna run, and the more it's gonna have inside its episodic memory, its trace memory. And if you look, okay, so. Okay, here. What you see here, it's the log. Basically, it's the log of our graph programs. Okay. So we have the log. We have the program call that called the main file. Okay. And then, oops, no, sorry. Okay, so here it's called the program call. There is so it's the first step of the program. Then it performs an action. The action is to have different have a purpose, have an objective, and a hope and a prompt. So basically, what we've done is we save everything that the HybridAGI is doing at each step. It's optional because you don't need that for the system to work. But if you provide a trace memory to HybridAGI, you will automatically save everything, every log of your programs. This is useful for the AI to remember what it has done, okay? But it's also important for you to be able to check if everything went right, etc. To be able to inspect the correct execution of the programs, basically. Okay. So it looked like some spaghettis, and we record everything. Okay. And based on that, sorry, there is a problem.
No, I was laughing about this spaghetti. The way you said it looks like spaghetti.
Yeah. So basically, we have this log memory, and basically what this is all about is just remembering the log of the already executed programs. Okay. So if you want to have an agent that recall its past actions to perform better at a task, you can do it really easily, thanks to the trace memory. Okay. Okay.
Sorry, another question. So
yes.
When you have these trace results and you want to take them back to the AGI to improve itself,
yes.
Is it going to improve? Is it going to use that to improve the like the weights in the neural network side? That's the neural side, or is it going to use that to improve like the symbolic side, the logic side?
So in HybridAGI, if we want to improve the system, once you have implemented your symbolic system, the symbolic system don't need continual learning. Okay. Once you implemented or you integrated some knowledge inside the symbolic system, you have to do it only once. But actually what is tricky is to have the neural network learn. Okay. So this trace memory, for example, could be used for replay. We could replay the traces and ask the system to try to figure out what went wrong or stuff like that. Actually, we didn't yet explore that because we have a lot of things to do to just, for now, integrate that that reasoning inside the neural network. But it's actually something that we want to explore in the future, maybe in the next years.
I see. So
we're gonna have some time. I'm sorry.
Yeah.
No, sorry. So the neural network is you're going to explore in the future updating the neural network based on this, right? So, but this neural network is not going to behave like LLMs, right? Is it going to be different to LLMs, or are you using another neural network?
No, currently the most efficient way to work with sequences is using transformers. So we are using LLMs. But if in the future there is some breakthrough and there is some other kind of neural networks, we will switch. We are not tied to a technology. What we are tied to is a concept. Our project is tied to neuro-symbolic programming and to concepts from this area of research. But if let's say next year or another, we can switch out the LLMs. It doesn't make it's LLM agnostic. The system doesn't really care about which neural network do you use for that. So the thing is, we just use the best ones that perform best at the task, but we are not tied to any kind of architecture on the neural network.
Yeah, so I think towards the end, I'm hoping that we'll have some time after the demo, because the question I had actually ties into about what you just asked, but in a more business case type way. You'll see what I mean.
Yeah. We can talk about that later on. The business model that we have is really simple, but it's simple, but at the same time it took us, because we wanted to do a project. Honestly, when I started HybridAGI, I started this startup not because I wanted to be rich or to anything like that. I just was shocked about how machine learning people was handling these problems and handling the agent framework and handling of that. We started the company because we had the competencies to work on that, and because nobody was doing it. So that's why we started that. So I can
that is really cool.
I can really explain you about the business model and why we think it's gonna be relevant even in the next years. But this is really tied to our vision and our thinking of neuro-symbolic system and why we need humans input and will always need human input. Okay, this is really tied to this thinking. I can explain you better after that. So, sorry. Now you saw, okay, that. What can I show you? Okay, we're gonna do the dynamical, so I can show you a really. So as you see, like you can have the end, you have the baseline. So the baseline is the score without optimization, and then you have the score with the optimization that DSP perform. Okay, and of course you can even have better results if you take really time to enhance your optimization pipeline using DSP, because currently in the example I just show the feasibility, and I didn't take that much time to enhance the result, but you basically you can leverage in context learning and do really good systems with the help of this automatic prompt optimization. That we can maybe plan another workshop on that, because I saw many people struggling to understand what DSP is actually about. I know DSP is a research project and they took inspiration from PyTorch, and not everybody is used to this kind of frameworks. So maybe it's gonna be the subject for another workshop, but not everything at the same time. So let's start the dynamic call agent. So what is the dynamic call agent? When you are making, so the first example that I gave you was just simple examples. They just involve not many programs and not many nodes in each program. But here in the dynamic call, what I wanted to show is how to create a program that is controlled and that have many kind of tasks. So you can, here are the tasks to like use correctly the how to say, the primitives actions. So they embed some logic to retry if something was not successful and stuff like that. Okay, but actually that's how you could make an agent that can perform multiple tasks, and that's even the way to make a system that can learn new tasks. So I saw previously, I think it's you, Baba, that asked me how the system can learn. So the system can learn by writing some graph programs inside its graph memory. Okay, so basically what you should do when you build a learning system with HybridAGI, so this is not a control. If you do that, you're gonna have all kind of problems that I talked before about the limitation of this system. Okay, but it's more a limitation of current large language model, and I don't think we're gonna it's really how to come up with good solution for that, and we are working on that. But it's except researcher, I don't think any people can really work on that kind of problems, because it's a state-of-the-art problem. But the way to make HybridAGI learning more tasks is to be able to write new graph programs, and also be able to call them dynamically based on the question asked. So in this example, I will load the programs, and I can show you the program memory, which is a new kind of memory that we had implemented in HybridAGI. to implement in HybridAGI. I can also talk about the funny story of why we implemented that. Okay, okay, that's good. So any program, actually, if you can inspect any program that was loaded inside the program memory, and you can have this this graph, and that the graph I told you before, that the one that you can tune, modify on the fly without retraining. Actually, this is the methodology that you just loaded in the cipher, and that's why we choose cipher for the domain-specific language, because one, it's easy for LLMs to understand it because it's based on an already existing language, and second, it's because it's really convenient that you work already on the knowledge that the graph database speak, in some sense, and so you are able to modify that and to check that and check everything inside the visualization software of the graph database. Okay. So here, like it's the main program of the dynamic call agent, and you can see program memory. No. Okay. Okay. So here is the dynamic call agent, and this is its program memory. So the program memory implements a dependency graph, like you would have in any programming language, to check for cyclic dependencies, or if you've made some mistakes on dependencies and stuff like that. You need to implement some kind of dependency graph, a dependency tree, to be precise. And here, the main advantage that we have with that structure is first, in each leaves. So here the gray nodes, you have you have the content inside this node is the cipher program that you just loaded. Okay. And this allows the system to be able to search based on similarity, to search for already program that it knows in memory, and to be able to modify them, correct them, etc. Okay. So, for example, you can imagine you run a program, you execute it, and at the end of your execution, you tell the system, okay, critique your output, how bad or how good the system performed. Read this program and make some conclusion and modify this program, update it to be able to learn, to have a continuous learning paradigm. Okay.
I love that. I really, because with ChatGPT, and some of these examples I posted them publicly. I do the same thing with ChatGPT, and you know what? It's such a mixed bag. It's not even funny. The fact that, like, just what you were saying earlier, the fact that as an LLM by default, there are limitations there.
Mm-hmm.
So yeah, I really, from what you're describing, it sounds like, this is impressive. Like, whereby it gives you accurate the way you would judge yourself.
Mm-hmm.
Love it.
So, sorry, Saif. Fabish is about to leave, and he asked a question. Johan, can you see if you can answer his question before he leaves?
I think my reception is a little poor. Is it really live? Okay.
Why we are not storing it in a text file? Basically, it's because
he's saying why you are storing it in a text file instead of like in a graph database format.
We
storing the answers in a text file instead of a graph database.
I already the answers are actually stored inside the graph database. They are stored inside the trace memory. so you can recall them afterwards. They are not stored in any text file. If you run HybridAGI, it will not produce any text file or anything, unless it's the everything is stored inside the graph database. Nothing is stored inside the text file, basically.
The text file is just the answer for like if you ask like a question, a given question, that's just the answer. But really, to talk like
you talk about the RAG about the RAG. The RAG about the file system RAG is just an example. It's just to show the ability for the system to store and recall stuff inside the text file, inside the file system. It's just an example. Why you would need that is because actually the task that someone, if you are working on making an essay, writing a thesis or stuff like that, you need some way to write into this file system and to recall and search for information inside this file system. But actually you can use multiple memories at the same time. You just need to use the corresponding tool.
I see, thank you. And I also have another question. So in what you're showing, what's the difference between this graph that you're showing that seems to be like the graph of the programs executing, and the other graph down, which seems like a start? I can see a start and an end. It seems like two different graphs.
So about the fun story, why did we decide to implement this dependency graph? Because we were experimenting self-programming system, okay? And when you explore self-programming system, you need a way to recall the programs. So basically, doing similarity search inside this program memory. But we noticed that sometimes the large language model wanted to modify its own main program, and it was really a rising concern about large language models. It's not conceivable to have an AI system that is able to program its own program, and we want to check that for every program that depends on the main program, we prohibit the system to modify its program. It's like you give a system the capability to reprogram itself. You want to have your word rails to not be modified by the system, and you want to have your main program where you will implement safety features to be untouchable by the system. That's why we implemented this dependency graph, because with that we can make sure the system can modify only the program that are disjoint from the main program. Okay. In the documentation, I've put an example. It's called safety first, where I kind of played with the first law of robotics from Asimov, and we implemented it in as a rule system, because basically Asimov law are natural language rules, and how to implement them, and how to make a robot system that cannot modify its own rules, its own principal rules. So that was the main goal. So this dependency graph allowed that. It protects the main prompting mechanism, because it's where you're gonna put the learning algorithms and where you're gonna put the safety feature of your system.
Yes, I understand that. Number one, it's great to see that you are thinking of AI not taking over the world. So that's fantastic. But the question I have is, so there's the dependency graph, right? So that shows like the relationship between the programs and the execution. But what is the other graph?
So the other,
this is the dependency. Yeah, this graph. What is this graph called?
This is the program. This is basically the cipher program that you load when you. It's the instruction that you write. It's the program that you have to come up as developer. This is it. Okay.
Okay. So you write this program, and this program
is a graph.
The execution of this program is the graph on top.
No, the graph on top is the. For example, here we have this node. Okay, this node is a program node, so it's kind of like a subprogram, like you would see in any other programming language. And here, this is this relation. So you have the main program depends on this program, okay? And this graph is constructed based on all the cipher programs that you load when you start the AI, okay? That's it.
I see. Thank you.
I'm sorry, but it's gonna I don't know if Discord. No, it's okay. I think it. No, we can continue. It's start to getting longer.
Like Google it. Discord doesn't cut you off, thank God. But
So the last kind of memory I can show you. I can run the test because I don't have an example for that right now, but I have some tests, so I can show you. But the last kind of memory, it's really I would say classical in knowledge system. It's just a triplet store. It's not fancy. It's we didn't had to come up with a new thing, but I can show you the test.
so on everything that you're demonstrating, you don't know what the word fancy means.
For me, fancy it's something that didn't exist. It's research, basically.
So this you're doing this you know like the demonstration is. I don't know if I'm the only one that gets that. So as it pulled up, let me just say real quick. Poetry, I remember that was the very first example, right? And so that's like a classic. The way I test ChatGPT, kind of I push it like it's push it hard, right? And then you just demonstrated something here where it's really meta-analytical, where like you're actually having it like grade itself. There are a couple of examples later on watching the videos. I mean, it's so I don't know. I just always like to have a big picture, like a recap of things, but the way to have the video, so.
What the? Okay. So last kind of memory. This is HybridAGI source code loaded in the fact memory. So the fact memory, basically, it's just a triplet store. Just a triplet store. It's not everybody is looking at that stuff, but for me, it's really basic because all my career is based on this kind of stuff. So it's convenience, but the problem with knowledge representation is that you have to come up with depending on the problem you have to work with. Your graph gonna have a different structure. And what's actually difficult is to model the knowledge in a way that is universal for every problem. So this is something I've put aside when I started HybridAGI, and that I start to, now that I finished every other aspect, I'm starting to look at this and to implement like software engineer agent and stuff like that. So basically, this is just
This is because software engineers love templates. Like me, I'm in like scripts and templates and stuff. So like it's funny how you were describing it as like only an our interest. No man, like engineers are gonna love.
No, for me it's not the main point of HybridAGI. It's a subtask. It's a task that we can have, but it's not the main point. I remember I'm working with robots, so for me what I'm interested in is more how to leverage and how to correct the defects of large language models. So this is useful for many use cases, but it's not useful for all of them. So it depends really on how you. And for example, if you look at Llama Index does just that. It works with Llama Index is a framework for RAG system, but it's not a framework, a real framework for agent system. And the agent they've implemented is basically based on Langchain or React agents and stuff like that. They are not really serious about agents. So, yeah, that's it. So here you can have the every classes, every functions, and you have in the contents, so the content of the functions and stuff like that. So you can have a software engineer that inspect the code, and you can load a whole folder of code and have this kind of graph representation to basically do graph rag and any fancy stuff like that. And the good thing is that you can build a graph rag by using that, but you can also use other kind of memory. You don't have, for example, you could build a program that's gonna check this graph, answer the question of the user, but also store the answer to not to be able to recall that previous answer based on another kind of memory, for example, the trace memory. Okay. And this is all about, that's why I put in the README that our work is really, we are building and we have built a memory-centric AGI. What's the missing feature of large language model is memory, and memory is not only vector. That's the main point of our work, and because the memory, it's also the procedure. When you are tackling a new task, you already know from your past experience what you need to do. You have kind of a program inside your memory, and you know that you have to, based on the errors you made, you know that you have to do this task, then this one, then this one, then this one. You based your answers not based on your knowledge that you just read from a paper or whatever. Yeah. You based your actual response based on your experience. Your experience is key. Yeah, that's it.
Yeah. Because a lot of the time, I mean, like really, when you think about it, what LLMs are missing, right? In large part, meaning doesn't come. Like really, at the end of the day, most of humans' meaning, right, day-to-day interactions or whatever, comes from like subtext and non-verbal, pragmatic versus semantic. And so we're very impressed with generative AI, and it can write a poem, it can draw art, and etc. But I really that concept of self-reflection, of a phenomenon of being able to self-critique appropriately, and that made us just so striking.
So here is it.
I look like I'm the only one left.
The only one left. So.
It was like, but it was a really cool presentation. So what I was gonna ask you, so like I'm always fascinated about, as you were talking earlier, right? Like I really like, I've read from some of the documentation or some of the like stuff you've written in the server elsewhere. I like the ethos of the company that like just you mean like
it's political.
I really like the fact that like you're trying to, you're not commercial just
Yeah.
So, but I really and like a lot of the time companies end up doing a lot of good. You can both do good, make perfect,
exactly,
but also like really
exactly. But you need a deep understanding.
Like seeding. Yeah, but so seeding wise and all that fancy stuff like where seeding stages and all that and like the business aspect of things, how far along have you gone with that? Obviously incorporation and like angel investors and all fancy stuff. I'm always fascinated to hear about. I don't know if
for us the business model we choose is what the thing is, we first thought about what were the constraints, what we wanted to do. We wanted to do ethical AI, safe AI, okay, explainable AI, and this you cannot do it by doing proprietary stuff. I'm sorry for OpenAI, I'm sorry for every companies that do that. They are just lying to people and it's never gonna work. You cannot do that. So you have to come up with a business model that integrate that fact. And what is really in neurosymbolic systems, this is not about the neural network. And again, this is about human. So our business model is to build a marketplace to allow programmers and researchers to sell their knowledge, and we want to take a commission from that to continue our research and continue our progress. We don't want to. The aim is to build a better world. It's not to. What's the matter to? I don't even. For me as a programmer, I don't want to live in that world. I want to live in a world where I can enjoy programming, I can enjoy building system, and I can leverage that to make some money and to live. Basically, I don't need any more. I just need some money. Money is not a. It's a tool. Money, it's a tool, and people tend to forget that it's a tool.
You know, but because it's funny how like everyone and I, you know, person that like being sarcastic here because my sarcasm is poor, so I have to announce it. You know, you gotta love